Here's an example about Eulerizing a graph in an efficient way. Now, what does that mean, Eulerize a graph? Well, remember, step one, put the number of lines, I should have said, lines that hit each point. So let's do that. How many lines hit this point? 3. 1, 2, 3 lines hitting this point. How about this one? 1, 2, 3. 1, 2, hit this one. 1, 2, 3, 4, hit this one. 1, 2, 3, 4, hit that one. Okay, so start with that. Put in how many lines hit each point. And I remember how it works. If they're all even, that means you have an Euler circuit that is possible. If there's too odd, that means there's an Euler path. So a circuit's a circle, Euler path. So we really, we want to create an Euler circuit, because that's the best. A circuit's a circle, and we'd like to have an Euler circuit, a circle. And so make every number even by duplicating, repeating some lines. So in other words, here's the deal. Suppose that this is a big city map, and there's different areas of the city that are, connected, or these are different houses, or a street cleaner needs to clean all these streets, right? If we see how here's the two problems. This one and this one are odd. The rest are good. The rest are even, aren't they? So those two are a problem. Now, definitely an Euler path exists there, but what we really want an Euler circuit. And for an Euler circuit, you have to have all even. So we want to make every number even by repeating some lines. So that's called Eulerizing. When you do that, it's said that you Eulerize the graph. Eulerize graph, which means make all even. Make all the numbers even. Right? Eulerize the graph means to, add repeats to make all of them even. That's what we want to do here. We want to add some repeats to make all of them even. That's what it means to Eulerize a graph. Okay, so how do you Eulerize this graph? Well, do you realize that if I just add a new one here, let me erase that because it might get confused. Let me just change the color. If I just add this street, really repeating the street that's already there, this now becomes 4, and this becomes 4. And now everybody's even. Why are we doing that? Do you see what's going on? Basically, we want to make them all even because then there's an Euler circuit when they're all even, which means there's a way to cover all these streets only once and make a circle and come back home. So you could set up the office here for the street cleaner. You could put it on any of these points. You could put it right there, and the street cleaner could start here, and he could go around the city, go this street, 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 and this street, and come back home where he started. You see, I just did it. I just did a circuit that started at B and covered every street exactly once and came back home to B. I made an Euler circuit. Now, in reality, I had to do this extra one right here, the new extra one we added, which really means you're not really saying we're going to build a new street there. You're just saying I'm going to have to use this street, the CB street, 2 times. That's the best we can do. That's the best fix to make a loop. So let's see if I can make sense out of this a little bit more for you. So the deal is we want to be able to, again, cover every street. Street cleaner wants to be able to whoops, I messed up here, huh? Well, a street cleaner wants to be able to clean every street. This was 3 and this was 3. Wants to be able to clean every street only once. You don't want to waste a bunch of time going back over the same street 2 and 3 times because you're trying to get back home to your street cleaner office, right? That's a waste of people's time and money. Businesses care about these things for postal delivery, street cleaning, garbage service, etc., etc. The list goes on all kinds of times in real life. You want a route, a circuit, where you start at your office, cover every street in the city, and come back to your office, and you don't want a bunch of repeated streets. Well, you can't do it when you have odd, right? An Euler circuit, that's what you want, has to be all even. The only way that you can do an Euler circuit, in other words, cover every street once and come home without any repeats, is if you have all even. Well, we don't have all even. We have a 3 here and a 3 here. Those are odd, right? So you have to fix them. That's called Eulerizing the graph. You have to fix it. You have to add a repeat. Now, again, that's a repeat. You can't tell, I'm just going to add right here. I'll add one right there. No, that's not a road that already existed. That's a brand new road. No, what you're saying is you're adding a repeat. You're basically, I'm saying we add this one right here because that's a repeat. I'm saying really we're going to cover the CB road twice is what I'm saying. We're not really going to build a new road there. By adding that, this now becomes 4. See how there's 1, 2, 3, 4 that hit this now? And this becomes 1, 2, 3, 4 there, doesn't it? I make them all even now. By adding this one extra street to the one that's already there, what I'm really saying is we're going to cover that street twice. We're going to need to go over that street twice. That's the best we can do. But at least it's only one street that's repeated rather than like 3 or 4 streets where we're wasting our time and money. So Eulerizing it is adding a repeat, right? A repeat, not a new street. Right, I already said you can't add one out here. There is no street from C to D. There's no street that runs from C to D. That would be a new street. We're not adding new streets. We're repeating streets that are already there. So when I add that repeat street right up here, I'm repeating CB, and I'm saying to make a loop, to make a circuit where we hit every street once, we're going to have to repeat that one street, CB. I had to add a repeat to make these both even. Now everybody's even. Now there's going to be an Euler circuit possible with the one repeated street. Let's find the circuit. Here we go, because it wants you to list it. So you can start anywhere you want. It doesn't really matter. I'll start at A. Here we go. And I'll go B. Oh, that was E. You better get that right. So A, E, D, back to A. Just covering every street once. Out here to C, down to E, up to B, over to C, back using our added street, which is really just a repeat of CB, and then down to A. See, that's perfect, isn't it? We made a loop. We started at A, ended at A. That's a circuit. And we covered every street exactly once, as you can see. So that's possible by adding the one repeat right there, CB. That's called Eulerizing a graph. Adding the least you need to add to make everybody even so there'll be an Euler circuit.